Hi there, we are from Group F, and together with me, we have Ahmad Arif, Divagar, and Navindran. So, the flow of our presentation will be introduction and explanation on our case studies, and lastly, the conclusion. So, the object that we chose for our analysis is a chair and is one of the important pieces in the furniture world. So, usually, the main part of the chair is built by two pieces of raw material joined at 90 degrees angle to make the vertical back and the sitting part of the chair, and is supported by four legs. And we chose the chair to be made out of 316L stainless steel. So for our case one for our analysis is sitting with both legs on the ground, while the second case is sitting and leaning with both legs on the ground.
Hi, my name is Navindran. So before we conduct the finite element analysis, we need to create the meshing for the chair frame. So when we are doing the meshing, we have to conduct the meshing convergence study. So to create the mesh for the finite element analysis, the convergence study is carried out to have a more accurate result. The mesh convergence study is done by decreasing the meshing element size until the von Mises node value and the element value have a smaller difference. As you can see from table 1 here, the difference is reducing as the mesh element size is decreased to 12 millimeter. So for this finite element analysis, we are using the smallest size available, which is 12 millimeter, which would give us an accurate enough result for the simulation. And also for a greater accuracy, we will be using a high meshing quality. But unfortunately, with using high meshing quality, the simulation times will be longer. For the finite element analysis, the first load case that we are using is sitting on the chair frame. So when sitting, the weight applied on the chair frame is a static force which is generated on the side center of the sidebar, and this is assumed 59.26% of the human body weight. So this percentage is taken from a human anatomic parts. So we are considering the top part of the body weight, and the human weight, maximum weight that we are considering for this study is 200 kilograms. So with the assumptions made to calculate the force acting on the sitting area of the chair frame, we use the average human weight of 62 kilograms and the maximum operational weight of 200 kilograms. We make the assumption that we are using only 59.26% of the body weight, since we are only considering the upper body, and from that we will get the weight of acting on the chair frame as 118.52 kilograms. So the force can be calculated by using the formula F equal to ma, where m is the mass, which is 118.52 kilograms, and acceleration is 9.81 meter per second squared. In that case, we will get the force as 581.3406 Newton. So with the meshing done, and then the load is assumed, and we can plot the load on the chair frame. And as you can see, the fixed geometry is also applied on the bottom four legs. So the simulation can be conducted, and the first maximum von Mises stress distribution plot is produced, the results. And from this plot, you can see that the minimum stress is indicated by the color blue, and the maximum stress is indicated by the color red. So the maximum swarm Mises stress that is obtained from this plot is 22.35 megapascal. Next is the deflection displacement distribution plot, and as you can see, the blue color indicates the minimum displacement, and then the red is the maximum displacement. So the maximum displacement occurs at the top bar, which means the chair has been deformed to uh, to the extent that the top bar is displaced at a higher distance, which is 0.2329 millimeter. And finally, the factor of safety plot. And from this plot, you can see the minimum factor of safety that we can use uh, for this chair frame is 2.852.
I'll be explaining about load case 2. Load case 2 is sitting and leaning force on the chair frame. The weight applied to a chair while sitting and leaning with both legs on the ground produces a static force. A load is assumed to be applied to the middle of the sidebar, indicating a normal load. A load is assumed to be applied to the vertical bar, creating a torsional load. The total weight used in this study is 200 kg, of which 20.1% is used for leaning and 39.16% is used for sitting. This is the calculation to determine the force acting on the body. There will be forces caused by sitting and leaning. For sitting, same as case 1, we use the equation of F equals to ma, while for leaning, we use the equation for torsion. 3 figure below shows the result collected from doing the simulation. The figure 1 shows the maximum bond missile stress, which is 143.75 megapascal. The second figure shows the maximum displacement, which is 4.709 mm, and the figure 3 shows the minimum factor of safety, which is 6.732.
As a conclusion, the safety factor value for the first case is 2.852 and the second case is 6.732. Both cases are still safe because the critical loading value is below 1. And we need to ensure the quality and the safety of the chairs before production is to ensure that the users are safe and sound.